I want to cover this subtopic, dilution of solution. I will handle this by an example that I'm going to give here. Now, dilution of solution, here I'm going to say that assuming we are given a solution of a 2 molar hydrochloric acid. Now we have a 2 molar hydrochloric acid. Now, assuming we are given a beaker, that is a 250 beaker with a solution which is 2 molar HCl. And this is a concept that we use in our titration. And this is something that is very key when it comes to handling of questions on titration. Now, we have this 2 molar hydrochloric acid. And when we pick 25, we pick 25 centimeter cube of that solution of 2 molar HCl. When we pick 25 centimeter cube of 2 molar hydrochloric acid, now this is the concentration of the acid. And using a pipette, we pipette 25 centimeter cube of this solution that we are going to transfer either to a volumetric flask or we transfer to a conical flask. So we are supposed to determine the number of moles in 25 centimeter cube of this acid, which is 2 molar. Now what we are going to do here, we know that this is a molar solution, and 2m, what this means, any value we are given in molarity, it tells us that these are 2 moles per liter, which is, in other terms, we can say 2 moles in 1,000 centimeter cubed. Now, we would ask ourselves, what moles are we going to have when we pick 25 centimeter cubed? Remember, this is a container. We have assuming these are the particles, assuming we can see them with our eyes, assuming we can see these particles here, and we pick 25, which is a very small portion here. So we are going to pick a certain number of particles, assuming this is how concentrated they are. Now we are going to pick this number, which is now we are going to get it here, because we talked of moles as a term that refers to the Avogadro's number that you know, 6.023 times 10 raised to power 23. But this is a very huge number. Atoms or particles, which is a very tiny. I've just indicated here so that we can assume we are able to see them. Now, what we have here is 2 times 25 divided by 1,000. So this is the moles that we are going to have. Remember, I'm going to show how we are supposed to dilute our solutions. Now, here, the next thing here, we are going to do this. When you multiply, we get 50. 50 divided by 1,000. So this is 0.05 moles. So this is the number of moles, the particles, assuming something that we can see, we are going to pick from this solution. Now, this one, we transfer this one. I'm going to show 2 concepts here, so make sure you are very keen so that you are going to get me. Now, when you transfer this to a conical flask, here we are going to have this 0.05 moles. So from here we proceed to titrate maybe with another solution, so that from here when we reach a neutralization, when the moles cancel each other, we are able to see an indicator change the color. And this is not what I want to show now. I want to show the case where we are going to transfer this, assuming this one is a volumetric flask. Volumetric flask, we have this one is a 250 volumetric flask, and we have another one here which is a 500 500 centimeter cubed volumetric flask. Here we transfer the 0.05 moles. 0.05 moles. Because we are transferring 25 centimeter cubed, 25 centimeter cubed of the coke, that is the 2 molar hydrochloric acid. We transfer here. What do we transfer here? So we have those particles here, and we have these particles here. So now we can be able to see the particles. Remember, the particles are very microscopic. We are not able to see them with our naked eyes. Actually, we can see the particles here. Now we have this solution, this solution. Then you top up with the distilled water. With water up to the mark. To the mark. Now when we top up to the mark, what we are going to get here. Now when we top up to the mark, what we are going to get here, we have now water. We are topping up with the water up to the mark. Now, the first question we are going to ask ourselves here, how many moles do we have? We still have 0.05 moles. But now the volume of the water that we add here, we are going to have different concentration. Same moles, different concentration. Now, I want us to see the concentration here. So if I had to ask myself, what is the concentration in this flask? I'm going to say that here I know we have 0.05 moles. The concentration here is 0.05 moles per 250 centimeter cube. But our concentration, what we call molarity, we want to ask ourselves molarity in this flask here, the volumetric flask, that is 250. What about 1,000? We cross multiply 0.05 times 1,000 divided by 250. So what are we going to get here? We are going to get 0.2. So this one will be the concentration in this flask. The other flask here we have 0.05 moles. The number of particles is there that are per 500. What about 1,000? (0.5) times 1,000 divided by 500. (0.1 molar). Now, this is the concentration here, and we have 0.2 the concentration here. Now, I want you to understand where we are doing this. So that now, when we are told, now from here, sometimes in an exam, you may be told to pick now another 25 from either this solution or this. So now we are given 250. The 250 volumetric flask. And now we add it to the mark. You shake so that the particles are distributed well. So that after that, you are supposed to pick either using a pipette, you pipette another 25 centimeter cube. These are concepts that I want you to understand. Now, when you pick 25 centimeter cube from now this solution, how many moles are you going to pick from there? Now, what you are going to say to do here, we know that the concentration in this flask. So concentration is the key that is going to direct us. We have 2 moles. To me, it's 2 moles. These are the moles that are in 1,000. centimeter cubed. But now you pick 25 again. So expecting to pick a lower number when it comes to the number of moles here. So what you're going to have here is that 0.2 times 25, then divide by 1,000. So when you multiply this, you're going to get 5. When you divide by 1,000, you get 0.005 moles. So this is what you're going to pick from this flux, so that you continue with your titration. It is from this dilution concept that we derive the formula M1 V1 is equals to M2 V2. This is the formula for dilution.